This is the third video in the Introduction to R module for our INSY 6500 class. And so in the first two modules, we talked about R and our R resources, features of R, outlined for our book coverage, talked about R Studio, and then in module 2, in video 2, we started talking about the programming language R and some of its aspects, and went and started going through the basic R programming script. And in this video, what we're going to pick up with is the object types. We're going to talk about factors and data frames, and then talk a little bit about our functions. So let's switch to R Studio. And again, I am working on our basic R programming. Oops, I need to get rid of all this old stuff. I'm not going to use any of that stuff yet. Get rid of, let me dump all this stuff. Clear, our global environment is already cleared. And so let's just pick up and start talking about factors. So in R, a factor is how we can represent categorical variables. So a categorical variable is something where the value can take on any of a finite number of options. And so here's an example where we're creating a vector. So we're just creating a simple data vector, and we have multiple values of east, west, north. I guess we don't have any south, of east, west, and north. And so when we look at our data, we just see this as a vector, and I guess an 11 element vector. And then we can use the isFactor function to say, is this factor data? And so when we execute that function isFactor, of course it's false because it's not. And we can also see that when we print the class, shows up as character, which it also shows up in the global environment. When we apply the factor function, though, we can create a factor using the data. So when we do that, we apply the factor function, and then we create factor data. And if we look at that in the environment, you can see that this is a factor with 3 levels. So the levels that we have, so by creating a factor, we recognize that there are 3 levels, the north, east, and west, and then we have the values corresponding to those. So internally, R stores factors as integers, and then with a corresponding set of characters that are displayed. So when you display the factor, it it shows the character values, but it's stored as the integer value. So when we look here, we can see that our factor has east, north, and west, and so the first one is east, second one is west, third one is east, fourth one is north, fifth one is north, and so on. So you can see how we're applying these integer values, but when we display these, so when we go and say, okay, well, first of all, we can print the factor, and you see the printed values and then the levels, east, north, and west, and then the printed values. Of course, when we do isFactor, yes, and then we look at the class and we show it's also a factor. So what this lets us do with factor data is it lets us do to store categorical values. And in R, that's primarily used in data frame. In R, a data frame is the typical way that we store rectangular data, or we store records and attributes. And we're going to spend quite a while talking about data frames and tables, which are derivative of data frames that I mentioned before, throughout the rest of the coverage of R. And also note that there are another 3 videos that talk about sample data frames, that talk about accessing values, and that kind of thing. And so all we're going to do in this video is just kind of hit the highlights, and then all of the detail work is going to be done either in those videos and in class. And so we can create I'm going to create employee data here. And note that when I did that, I have employee ID, which is a sequence from 1 to 5. I have 5 employee names. I have 5 different salary values. I have a start date, and I use the asDate function to convert these to dates. And then I said I want to have strings as factors false because I don't have any categorical data. So even though I have the strings that are the name, Rick and Dan, Michelle, Ryan, and Gary, there's no factor information there. So these are not categorical variables. These are actually string variables. So I wanted to set that to false. And so when I look at employee data, you can see that I have 5 records or 5 observations, 4 variables of each one. I have the employee ID, the employee name, the salary, uh, and um, and the start date. So I can also print that value. So if I print, I just see a different view. I can also specify if I do have categorical data that I'd like to store that as factors. So in the second data frame that we create, you note that we create a set of heights, a set of weights, and then we have genders. And so gender, male, female, and so this is categorical data. So whereas the names were not categorical, they were just character data, in this case, we do have categorical data. So what I'm going to do is I'm going to create a data frame, and then instead of string as factors equal false, I'm going to set string as factors equal true. And so now when I run and I look at my input data, we have the 7 observations, and we have gender, and we go back to and view those values. So now when I print the value and then print as factor, this is true. So now the input data gender is categorical. And so if I just print that column, right, and so I can do that again, I'm pulling off that column of the data frame with the dollar sign. I do that and I say, okay, this is a factor data with 2 levels, female and male, and then the corresponding factor values. And so again, there are 3 videos on and the script sample data frame. So if I go look at the sample data frame script here, let's just look at that really quickly. So sample data frame, there is a 3 video module that goes through this, where you actually go through and access values in the data frames and do uh, um, more detailed work in looking at the data frames and how we use those. For this module, I want to stop at that, or for this video, I want to stop at just a basic definition of a data frame, where it's our main mechanism for storing rectangular data. And so we have the columns, which each have a data type, and we have observations. So again, in that context, they're very similar to the data frames that we saw in when we did pandas in Python. And so the next thing I want to do in this module on the general programming is to talk a little bit about functions in R, because we see this quite a bit, and we've actually seen uses of functions throughout the example. So I wanted to go ahead and just give an introduction to how functions in R work. So we have a function name. In this case, we are assigning the function here. So you can see the function call and the assignment operator. We're assigning that to a function name. We have optional list of arguments, and then we have the function body. So let's go back and look at that in our sample. And so we created an inspect function. So this would be, the inspect function in this case would be roughly equivalent to what we saw as the show functions in some of our Python script. So I'm defining this function, and you send it a parameter, x, an object, and then we have a show parameter, or a show function, which is optional and has a default value of false. And so when we execute the line to create the function, we now have, if we look over at our global environment, we have a function called inspect. It has a parameter x, which is required, and then we have an optional parameter which takes the value of false. If we look at it if we look at the function in our file view, you can see that we actually see the code for the function. So then when we execute the function, we simply use the function name and then the parameters. And so the first call, we have 27.5, and we send a true value, and you can see we show the class is numeric, the type is double, the mode is numeric, structure is number, and then finally we've said we wanted to show the object, so it's 27.5. So we just showed that the value. If we execute the function without that second parameter, you can see that it did everything. This time we sent as integer as opposed to as numeric, and so we see that the class is integer, the mode's numeric, but we don't actually show the value because we left that optional parameter off, and so it defaults to false. We can then use another couple of examples. So in the case where we send a vector, three values, or a 3-item vector, then a 3-item vector, in this case of character values. We send a list, so we have a single value is a list, but the list has 3 elements, and so on. Or we can send a data frame. So basically, when we define that function, its function definitions are the same as we saw in Python. The syntax is a little bit different, but we have a set of parameters. We can have optional parameters, and we then have the code block. And when you call the function, the calling parameters are used and that are executed, and then anything that's displayed, you see if it's returned, then you have the return value. So we'll see functions used as we look through, as we continue looking at code. One other thing I wanted to mention before we go forward is something called lexical scoping, and this has to do with visibility of variables. And so we have an example called uh, lexical scoping example in R. And so what we do is we define a function, and then we call that function. And the question is, well, what would you expect to see? So what would the output look like? So if I were to set y equal to 207, call my function with a value of 13 and b, and execute, what would we see? So let's go back to R and lexical scoping example here. There's our lexical scoping example. And you can see that I've also added a little bit of text since I created the PowerPoint. And I'm going to come back to this, but this video or this site, this is the programmatic data, or R Programming for Data Science book that I mentioned back in an earlier module, has a nice video in addition to text that goes through this lexical scoping concept in detail. So I'm going to show that here in just a second, or show you how to access that in just a second. But here's the code that we have. And so you can see if I just execute this, let's clear the environment first to get rid of all of the stuff that we've already defined. So I execute that, and now of course you see function. I have a function with a single parameter x, and what that parameter does, close some of this stuff too, close my data frames. Yeah, get back to lexical scoping. Right, so what the function does is it takes a parameter x, and then it defines 2 variables, a and z, and then it prints ls, and ls is the essentially the list that you see, the environment list, and then returns the z value. And then we execute that. We define a y. So if I do that, I define a y, and then I define b by using the function. So I just executed the function. And when I execute the function and send a value of 13, what it did was it defined something called a, gave it a value of dog, defined something called z, where it added x and y together, then printed ls. So now that's what we see right here. So we see ls, we see the environment, a, x, and z, but that's not the same environment that we see here. And that's because the environment that we see here is the defined with respect to this function. So the function itself has an environment that we don't see in the global environment. And then when we print ls here in our call, we can see b, which we just defined. We can see the function, which we defined earlier, and we can see y, which we defined earlier here. So we see things that are in the global environment, but we don't see into the local environment defined by my function. So this idea of lexical scoping basically says how you access what are called free variables. So let's look back at my function, where we pass a value of x in, which we say right here. We define a, we define z, but z uses x and y. So x comes from the parameter list, but where does y come from? Right? So we sent a value of 13. What gets returned is added to 13 to b, and so clearly it's 207. So the y value is retrieved from the global environment. And so that's an artifact of this lexical scoping. And what that means is that we can define the or we can find the value of a free variable in the encompassing environment. So the function is defined with respect to the global environment. And so the free variables in the function, in other words, the ones that are not defined inside the function, are retrieved from that global environment. So if we look at the reference that I gave, so go back to the reference, and oops, I guess I don't have that, so I don't have it pulled up yet. So let me go back to my R, and let's grab this guy. So this should go directly to it. So we'll copy that and go back and grab that here. And so here's the scoping rules of R, and goes through all of this in detail, all of the detailed scoping rules and how to interpret these and so on. And as I mentioned, there's a nice video. So if you click on the video, you can see a YouTube video where the author of the book talks about the details of the logical scoping rules. So let me stop that here and let you, if you're interested, go see that on your own. But again, what I wanted to point out is as you build functions, it's important to understand how these scoping rules are applied. And so the easiest way to think about it, if we don't get too deep into levels of hierarchy, because you can actually have functions defined inside functions, and there's a progression of rules for this lexical scoping. Again, that's all described in the book. But from our perspective, the easiest way to think about it is you can just look at the encompassing environment. So in this case, I've defined my function in the general environment, and so that means all of the variables defined in that general environment are available to me inside the function. So the last thing I want to cover in our basic R programming. When we talk about the pillars of programming, we've already seen assignment. We've seen lots of applications of assignment and the implications of sequence. So we understand that the sequence with which expressions or code is executed impacts the behavior. So the last two things we need are selection and repetition. And so R has support for both of those. So we have traditional if statements, as you can see here. So I've just assigned the value of x to be 400, and then I say, well, if it's less than 200, print yep, otherwise print nope. And so of course it's going to print nope. So just a traditional if statement. I also, create a vector of what is truth, and then I can say is truth in x. And so, of course, it is truth is not found because we have capital truth, and we don't have capital truth here. So again, if I change that, if I just back up, and make capital because it is syntax or capital is, what's the word I'm looking for? Different. So a capital T is different than a little t. And so now I do truth is found. So if I do little t, case sensitive, that's the word I was looking for. So in our original invocation or original definition, we have lowercase t. So what is truth? And so we say, is truth in x? No, of course it's not found. But when I capitalize in our value, and I say is truth found, then of course truth is found. So again, just two little demonstrations of using selection. Repetition, we have several different forms of loop. So we have a traditional for loop. So I'm just going to have letters 1 through 4, and then I can print those values, so A, B, C, D. So for I and V, so again, we're just going to step through exactly like we saw when we saw for loops in Python, where we have a vector, and we just iterate through those. I can also have my while loop, have a while loop, and so I have a condition. So here I'm going to set, v is equal to hello, and while loop, and then I'm going to set count equal to 2. And so while count is less than 7, I'm going to just increment that value. And so it starts out with a value of 2, then go to 3, then 4, then 5, then 6, and of course when it gets to 7, it's going to kick out of the loop. So again, a traditional while loop. And then R also has what's called a repeat loop. And so if we execute the repeat, basically what happens is it repeats forever until you break out. So in this case, I'm going to repeat. I guess I didn't go into that one at a time. I didn't execute that one at a time. I just executed the repeat. But you can see what happened is I set count equal to 2. I printed V, I then incremented count, and then if it's greater than 5, I break out. So again, it breaks out when it gets to 6, when it has that has that value. So we will see these also, again, the traditional um, um, uh, implementations of selection with an if statement or different forms of an if statement, and repetition with our three different loop functions. And so in summary of the basic stuff that we did, we talked about variables, we talked about data types, we talked about the frequently used objects. In particular, we focus on vectors and data frames. And so we have lists and matrices, arrays, and factors also, which we'll see, but our primary focus is going to be on using vectors and data frames. We talked about functions in R and corresponding lexical scoping, and then we finished up with the selection and repetition mechanisms in R. And so that concludes this video, and that concludes the 3 video series for our introduction to R. You should have a look at these, and also, as I recommended from way back in the beginning, if you look at the tutorials, point tutorial or other tutorials in R, you'll get a little bit more background in application of R.